Hello everyone, we're back again. Throughout this webinar, please take advantage of this opportunity and use the Q&A function at the bottom of the screen anytime you want to ask a question. Collectively, we will do our best to answer. Otherwise, we can take on notice. The presentation slides and the video recording will be shared with everyone later, so don't worry if you don't have enough time to take notes. To begin with, we'll have a short presentation by John, followed by an open panel discussion involving you as our audience. Now I would like to pass it over to John.
Good evening, everyone. My name's John. I'm the Deputy Head of School of Chemical and Biomolecular Engineering at the University of Sydney. And I'll be talking a bit about our university, our faculty, our programs and the student experience tonight. And we're happy to take questions at the end, and we'll just do our best to answer those. So first of all,
sorry about that, we're just having some technical difficulty. You could just hold on for a moment.
okay, so sorry about that. There's a small problem with the projection here. First of all, a little bit about the University of Sydney. We're ranked #1 in Australia and #5 in the world for graduate employability. And I think the year before we were running #1 in Australia and #4 in the world in the same survey. So we do a lot of things here to make you employable during and particularly at the end of your degree. So why would you study chemical and biomolecular engineering? Well, chemical engineers look at how you turn raw materials into useful products. How do we manage resources? How do we protect the environment? And how do we improve people's health? Chemical engineers are trained to meet challenges faced by a whole range of different industries, including the chemicals industry, minerals, energy, food and beverage, and pharmaceuticals. Our degree has an embedded honours thesis. All students do a research thesis. Our school has a number of research centres and hubs looking at areas like waste, food, and infrastructure. So we've got quite a number of interesting research hubs. And we're Australia's first university-level chemical engineering program. Now, if you study chemical engineering, you'll be learning from leaders in your field. You'll be applying skills in chemistry, biology, maths, and physics to work in a whole range of different areas. So we have students who go to work in biochemical engineering industry, the traditional chemical industry, who work in energy, both conventional and renewable. Environmental is probably one of our biggest and fastest growing areas, and food and water. So that there's a wide range of industries where our graduates go. Now, when you study chemical engineering, one of the things you learn is about scale. So you understand how processes work from down at the atomic scale, where you're thinking about almost individual atoms, right up to the macroscopic scale, where you're thinking about how things work globally. So for people who are working on energy, they might be looking at global trade flows and greenhouse gas emissions, but they might also be looking at some kind of catalyst right down at the atomic scale. Chemical engineers integrate their engineering and scientific knowledge to tackle complex problems. Okay, my current 4th year design class are looking at how do we convert lithium ores into more valuable products so we can export them and make more money as a country. Chemical engineers are trained to develop solutions to tomorrow's problems. So we have students in class in 2nd, 3rd and 4th year thinking about how to solve some of the big challenges facing society. So things like renewable energy or low CO2 energy, food, new sort of medical devices are all kind of questions that will come up in your classes. And chemical engineers have to learn to balance technical, economic, environmental and social priorities. It's not just about solving technical problems. And we hope, and we see it in our students, that they grow to be the industry and business leaders of tomorrow. Okay, our qualifications are recognised globally. We have 2 accrediting bodies that visit us every 5 years, and they're visiting us again this September. So one's called Engineers Australia, who are Australia's national engineering body, who look after all kinds of branches of engineering, so chemical, civil, mechanical, and so on. We also have another accreditation visit at the same time, from the Institution of Chemical Engineers, who are a British-based but global chemical engineering body. And so our qualifications are recognised by both of those, and they're recognised by the Institution of Chemical Engineers for our standard chemical engineering degree and our combined degree with science as being equivalent to a UK 4-year master's degree. Now, across our faculty, so the Faculty of Engineering, beyond just the School of Chemical Engineering, we have a big emphasis on trying to make students be ready for industry and to lead industry when they complete their degree. So we have a program here called the Professional Engagement Program, or PEP for short, for students to build up their sort of hours of professional engagement activities over the 4 to 5 years of their degree. And so there's sort of waypoints at the end of first, second, third and fourth year. The aim here is for students to gain some industry experience and start applying their engineering knowledge as early as possible to, take on some real world challenges and come up with some innovative solutions, but also at the same time to start building their professional network with engineers in their field and other field. And so at the end of their degree, be career ready. So there's some hours down here below on the slide, which you can pay a little bit of attention to, where there's things like site visits, guest lectures, industry seminars and so on. Another area of internships and placements where you're paid to be working in engineering. Then there's a few other areas which are for non-engineering activities, so clubs and societies, volunteering, or going on exchange. And the university has a plan here that 50% of our students at least will go on exchange within a few years. So, and there's some reasonable sums of money around to help with that. And we've also changed our semester dates slightly so that our mid-year break is long enough for short exchanges through June and July. Okay, now the university and individual academics have a lot of industry links. So I've just got a few logos there from around the faculty and a few that are specific to chemical engineering. So you'll hear a bit about AB Maori later when Claudia talks. Other companies who chemical engineering has big links with the BOC and Sydney Water. We also have some links with ResMed because they were founded by one of our former staff members. The faculty has a consulting business for students called Jacaranda Flame, where quite a few of our 3rd and 4th year students will get some industry experience solving problems that sort of government and sort of state and local government bodies and others have brought to the faculty as challenges. But we also want you to get some non-engineering focused activities. So this could be extracurricular clubs that you're in, volunteering, whether that's sort of in a welfare kind of organisation like the Salvos or Vinnies, or it could be something like the SES or the Rural Fire Service, or going on exchange. And all of those skills are useful because when you graduate, you'll be working with a lot of non-engineers. So that experience of working with others is really valuable. Now, for partnerships and opportunities, the university faculty has a lot of links. Our school has its own links, and the faculty more broadly has links, and then the university has links. And so there are links to prestigious overseas universities like Harvard, Imperial College London, Stanford, Tsinghua there. There are links to companies, so Johnson & Johnson, Accenture, Telstra, Google, Blackmores. I know one of our PhD graduates has recently joined them. And then there are research bodies, so like CSIRO, World Health Organization, and so on. So there's a lot of different links at the school, faculty, and university level that you can take advantage of. Now, the faculty has a program called the Industrial Placement Scholarship, or ESIPS, if we want to give it a long name here. And these placements could be in Australia, so they could be in Sydney, they could be somewhere in regional New South Wales, they could be somewhere else in Australia, or overseas. So from our school in Chemical and Biomolecular Engineering, in the last few years, we've sent students to Japan, China, the US, the Netherlands. This year, we have a student who's in Thailand. We have students in regional New South Wales. We have students in Victoria. We have students in South Australia. We have students who are based here in Sydney. And those students will be taking the first half of their final year from January through to July to work full-time on on a problem that's pretty significant to the business where they're working. And that project will take the place of some of their subjects as well as their final year thesis. And in doing that, they will finish their degree in the same length of time with 6 months of great industry experience and to have been paid an $18,000 scholarship while they were doing that. Now, to get into this program, it's quite competitive, and we interview students in third year. You need to have a good average around 75 or higher, but also a good level of maturity that we could send you, for example, to Saudi Arabia to work at the world's biggest petrochemical complex, and that you wouldn't be overawed by that. So we do go through a selection process there with interviews, but we do that in the second half of third year. There's a lot of exchange opportunities, as I mentioned. The university is really keen to send at least half of the students on exchange. Now, from the School of Chemical Engineering, we've got some quite long-standing exchanges with Imperial College in London and KTH, which I don't know the Swedish translation of, but I think it's Royal Stockholm Institute of Technology. But the university and the faculty have a lot of other exchange options. Now, they might be for a full year, a full semester, a winter school from Australia to the Northern Hemisphere summer, or a summer school from Australia to the Northern Hemisphere winter, or somewhere else in the Southern Hemisphere. So there's a lot of different options there. And there are some global mobility scholarships and other options there for students to help with the cost, because we recognise going for a whole year is expensive, but going for 6 weeks may be a lot more affordable. Now, to get into chemical and biomolecular engineering, we have some fixed entry requirements. So the New South Wales HSC ATAR is 92. The IB score is 34. And if the international ATAR is 85. Now, our assumed knowledge, and this is very strongly recommended, is that you've done HSC Mathematics Extension 1 and you've done chemistry. Now, if there's anyone listening who's in year 10 or 11 and you're interested in chemical engineering, please make those choices. If you're interested in engineering, please make sure you choose HSC Maths Extension 1 and the science that sort of best fits your area of engineering, so physics, chemistry, or possibly biology. The university from, I think, this year and definitely next year has maths prerequisites. So we will not let you into engineering without 2-unit mathematics band 4 or above, or a 3-unit math or a extension 1 or extension 2 maths. And for those of you who are taking the IB, that's SL or HL, with the SL level at band 5 and the HL at 4. Okay, so the reason why we brought those in is the small number of students we had coming in with maths below that level tended to fail, and it was just not a good idea for them to be undertaking engineering, because it was basically costing them a year of earnings if they caught up. Okay, that's 1 year of their career they don't see. So we very, very strongly recommend HSC Maths Extension 1, but the absolute minimum is Mathematics 2-unit band 4. Okay, what will you do career-wise? Well, the graduate salaries are in the order of 68 to 72,000 per year in the first year. Some of our graduates go to work for large-scale chemical or other plants, improving the production. So they might be in a dairy processing factory, a plastic factory, a ceramic factory. Some are in pharmaceuticals, metal, biomedicals. Some of them are researching about how to, say, make the next generation of batteries. Quite a few students go to work for environmental consulting companies to actually look at how do you protect or remediate the environment. Quite a few students will go on to research, particularly in areas like tissue engineering. So how do we sort of regenerate bones and muscles and so on? And quite a few of our students actually go off to work internationally. Now, it's not just our international students. Some of our local students will go overseas on graduation to work. Now, in your degree, you have the option of taking on a major. So we have a major in something called process intensification, which might sound like a bit of a strange word if you're not a chemical engineer. But process intensification is about making processes smaller and more efficient. So the idea that rather than having a large chemical plant to make a large amount of chemicals that you then ship around the country, you might have a number of very small chemical plants that make the chemicals just as they're needed at the site where they're needed. We have a major in water and environmental treatment processes because that's a major area where our graduates find employment. And we have units there looking at water, wastewater, membrane processes and so on. And we have a major which will start from next year in food and bioprocessing, where we look at, as the name suggests, food production, food processing. We look at biochemical engineering and sort of how those two interact. So if you're interested in those majors, that's something you'd select in your first, second or third year of study here, okay? To get into chemical and biomolecular engineering, for those of you who are in Australia, it's an entry via UAC, the University's Admission Centre, and you choose BE Chemical and Biomolecular. Now, if you're interested in a combined degree or flexible first year because you're still deciding, or you've got an offer for the DL Scholars Program, they have a different entry code in UAC, but you choose your stream of chemical and biomolecular engineering on your enrolment day, okay? And we offer a fairly wide range of combined degrees. So we have a combined degree between Bachelor of Engineering, Bachelor of Arts. Now, most people who take that, it's because they're studying a language, but there are some who study philosophy, psychology, and there will be some studying music because our Bachelor of Engineering, Bachelor of Music will be rolled into that program. Bachelor of Commerce is one of our more popular combined degrees. People are often looking at finance, but they're starting to have other majors like business analytics and marketing. We have 1 or 2 students a year do a combined degree with law. And we have a very popular combined option with science, which includes medical science options. And we also have a combined option with project management. So we've got quite a wide range of combined degree options.
All right, thank you so much, John, for sharing the information about discipline of chemical and biomolecular engineering, as well as our degree. So I'm sure our audience now should have some general ideas about the degree content and structure, the career prospect, our research priorities, but I'm sure they'll have more questions about details of those aspects. We're now going to open up our panel discussion. And please send through your questions via the Q&A board. And for those of you who missed our introduction, so just to let you know that we have the Deputy Head of School, Professor John Kavanagh here, and also a recent graduate, Ms. Claudia Moratti. So Claudia completed her combined degree with Bachelor of Science, and she's currently doing her PhD. So to kick us off, Claudia, could you tell us why did you choose Sydney Uni or CBE at the first place? Were you thinking about other degree options or other universities?
Sure, Dennis. So for me, it was always the University of Sydney. I don't really have a good reason why. Something my best friend and I kind of decided when we were very young. There was just something about Sydney that felt right. But obviously, when it came time to make a choice at the end of year 12, I visited a few campuses, and Sydney ticked a lot of boxes for me. So it was a lot easier to get to than some other options. The facilities were really impressive, and so were the research staff and the researchers that I spoke to. The academics on campus were really impressive. I also felt at home on campus, and I think that's something that is underrated when you're choosing a university. It has to feel right, and Sydney did for me. In terms of other degrees, I was always set on doing a Bachelor of Science. Engineering was something I kind of ignored in high school. I didn't really know much about it, and I made the decision to do a combined degree with engineering maybe a few days before my UAC preferences were due. It wasn't something that I was really informed about at all, but I thought it would help with employability, and I thought it could be a really useful skill set. It was something I was interested in knowing more about. And for me, chemistry was my favourite science in school. I wasn't that interested in physics, so chemical engineering was the natural kind of addition for me.
Hey, Claudia, since you mentioned that chemistry was your favorite subject in high school, would you have a question from the audience? So what subject do I need to do in high school to get into chemical engineering?
Yeah, so John touched on that in his presentation. Maths is the only prerequisite from a university level, so you won't be allowed into the degree unless you have that mathematic 2-unit or equivalent if you don't do the HSC. I would highly, highly recommend doing chemistry as well, or at least doing a bridging course if you're already in year 12 and that's not an option for you. There are so many things that you need to cover first in your both in your first chemical engineering subject that you'll do in semester 2 of your first year, and also in the other requirements of your degree. So when you enroll in a chemical engineering degree, during your first year, you'll be required to do chemistry in first semester and second semester, and both of these will be very, very challenging if you don't have any prior chemistry experience. So I would really stress the importance of doing chemistry. And mathematics as well, same kind of situation. In both first and second semester, you'll be doing mathematics subjects straight away. You'll do 4 of them in your first year, and having an inadequate, kind of level of maths, it will set you up for a really hard time.
Yeah. So the very simple recommendation for those of you in New South Wales is you should be doing Extension 1 mathematics and chemistry. And there's a whole lot of other subjects beyond that are good and interesting, like physics is good, biology is good, economics is good, English is good because you've got to write and communicate with people. So there's a whole lot of other subjects that are really good and useful, and you can't do all of them. But the 2 you have to do are 3 unit maths and chemistry.
Cool. So now we have an interesting question. What do you think is the coolest thing about biomolecular and chemical engineering?
Would you like to start?
Oh, I'll let you go first, Gloria. So.
Oh, the coolest thing. I think what I really appreciate most about the skill set and the degree is how it's changed my perspective. So something that you don't really think about very much, or maybe I didn't think about before I studied engineering. You don't really think about exactly how things are made and where they're coming from, and you don't really understand the scale of production. So even just being exposed to, food processing plants and chemical processing operations, you really understand, how big some of the flow rates are, how big some of the inventory is. And it really blows my mind, because then you look around the room, you look around your home, and you see, small products, but having a chemical engineering degree kind of gives you an appreciation for how difficult or how much thought has gone into how each of those things are made.
I think for me, it's probably looking at it from being a little older and having done a bit of work over the years. It's some of the cool projects that I've got to work on. So last year, I got a call from a former student running a groundwater treatment plant that was having a few issues. And this to go and do something I hadn't looked at for a while and be able to say, okay, this is how you could improve how your plant's operating. Or working with students while they come up with a new way to make a vitamin or things like that. So the sort of weird and wonderful collection of projects that you can work on is probably what I think is the best thing.
I think as well, it's so easy to apply the same concepts to something microscopic or, even, something genetic as it is to, if you were building something on, a huge scale. So the process behind, designing an oil refinery is very similar to the process of designing, a microscopic or really small process. And so it's really exciting how transferable the kind of tools that you learn actually are.
Thank you so much for sharing. I think I agree that also we feel amazed by the ideas provided by our peers working on the same project. Now we have a question about exchange. So the question is, can exchange take place in the United Kingdom? John just mentioned that we have strong partnership with the Imperial College London.
Yeah. And we also have, a faculty or another partnership with Edinburgh in Scotland. So we have at least 2 options in the United Kingdom, and there could be more from the university through various study abroad mechanisms.
Yeah. The one thing that I would say, just to be aware of, obviously, the United Kingdom is on a different academic roster to us, so their semester dates are different to ours. So if you are looking at going on exchange, the dates that you're actually studying abroad will be different to what your semester dates here will be. So you might need to plan accordingly, whether it means you're going over Christmas time or over the European summer. In July, something you need to be aware of.
The general advice we give anyone for exchange is you need to start planning about 12 months before you plan to leave. And if you do that, it can all work very smoothly and be a great experience. So yeah, we have links with Imperial College London, Edinburgh in Scotland, and there are probably others through the university that are still building on.
Thank you for sharing the tips. Continue on the exchange or study abroad question. So outside the traditional year-long or semester-long exchange, a lot of students do short-term programs. So Claudia, here you have done the short-term competition in the United States. Would you like to tell us more about it?
Sure. So in my third year of my undergrad degree, I participated in a project called iGEM, a competition called iGEM, which is the International Genetically Engineered Machine Competition. And it was started by MIT. It's run out of Boston. And so I worked in a team of 8 people, other science and engineering students here at the university. And we started in around April, and we worked on a project alongside our studies until October, where we got to go and present our research at a jamboree with about 5,000 other people representing over nearly 200 different universities around the world. At a jamboree in Boston. And it meant that my time overseas was only about 3 weeks. The competition itself was only 5 days long. But I had the opportunity to work on a project for about 8 months. So it was a cool way to extend a different exciting experience and still have exposure to that international stage. And one of the really cool things about iGEM specifically was that they really encouraged collaboration between international teams. So it was looked really kindly on if you had international collaboration. So we got to work with many teams around the world. Specifically, some of the teams in Germany were really helpful to us. So we had kind of a different international experience.
That's super cool. So I have a question about a typical workday for a chemical engineer.
That's an interesting one because it will really depend on the kind of role that the engineer's in. So for some, if I think of my graduates or sort of classmates, if they're in a production plant-based role, they'll be generally physically at that production plant. They'll be looking at sort of performance data from their plant for the past day or two to see how it's running and how things are operating. Mm-hmm. They may be organising maintenance or deliveries of raw materials or sales of products, and so on. Now, for others who are in maybe a consulting role, their day could consist of going to visit clients, working on the project for clients, and so on. Other people might be sort of in a more general management or a sales role. So there's quite a few engineers who will graduate and become what's called a sales engineer, where they're actually designing and selling equipment. And so again, they'll be going out to visit customers, finding out what the customer wants, and then working out what the customer really needs, which is not always quite the same thing, and then making recommendations and designing equipment for them. So it really depends a bit on the role.
Absolutely, and also involves different skill sets. So a question about the work experience. So the question is, did you partake any work experience during your undergrad degrees? If so, where and what did you do? So we mentioned that there's a compulsory placement component in the degree. Yeah. And also we have the professional engagement program to help our students to prepare for the career. So I know, Claudia, here you have done a placement with AP Maori.
Yes. So when I did my undergraduate, the PEP program wasn't in place yet, but we did have to do a mandatory 12-week work experience placement in our penultimate year. But I was lucky enough to receive an ESIP scholarship, so that covered the requirement, the internship requirement. So I had a 6-month experience at the start of my 4th year, working full-time for a company called AB Maori, who specialise in baker's yeast. And they were based in North Ryde. I was working at their research centre in North Ryde. And I got to go to work every day as a junior process engineer. And I guess I had my own project. I had a mentor, a supervisor, and I guess my tasks really varied from day to day. Some days I was working in the pilot plant, running experiments, trying to characterize a new product. Other days I was working in Excel, developing spreadsheets, models for a plant that I was designing, all sorts of things. So it was a really, challenging experience at first, quite intimidating to think about, starting to work full time as an engineer when you haven't finished a degree. But everyone is so accommodating, and people in industry, in my experience, are so willing to help you learn. And it was the best experience I've had. Definitely. And I've made some really good business, relationships. Yeah.
That's good. And some of our audience are very keen. They're asking that can they actually participate on campus workshops in year 11 and 12? So I know that the School of Chemical and Biomedical Engineering have the year 10 work experience program. So the students will participate in the week-long program, and they will be working with our PhD students on experiments. And for year 11 and 12, we do work with Engineers Australia to organize some of the summer school and winter school for the high school kids. So if that's something you're interested, please do check out our high school page on the faculty website. So there's another question about, are there any alternative entry pathways specifically for female engineering students? And or general alternative pathway, is the 92 ATAR compulsory? And the answer is yes. We do have different pathways suited for different situations. So please do check out that alternative pathway page, and we'll be sharing information via email later.
Yeah, I think another point there is that the percentage of our classes that have been female has been above 30% for about 25 years.
Mm.
And in the most recent couple of years, it's almost 50-50.
Yeah.
So for young women who are in the audience, it's not unusual to be a female chemical engineer. And even around our entire faculty and across all the schools, it's about 25 to 30% female now.
Yeah.
So
I mean, I'll be honest, in my experience, I didn't even notice the ratio of male to female in the classes. It's not something you really or that I was ever really aware of. I will just add with alternate pathways, if you don't qualify for one of the special admissions pathways that Dennis was talking about online, if it is just a matter that you didn't get the ATAR required, I would recommend enrolling in a Bachelor of Science at the University of Sydney, because you can take very similar subjects in your first year as what you would for your first year of chemical engineering. So if you look on the CUSP portal online, that's the CUSP portal, if you just Google that, you can see what subjects you would be required to do in the first year of your chemical engineering degree, and you can just select to do those or most of those through a science degree instead. And then at the end of your first year, if your marks are adequate,
it's about a 65% average to transfer,
which is very achievable, and you can apply for an internal transfer, and you may not even have to extend your degree at all, because you will have done the required first year subjects for your engineering degree. So that's something to keep in mind if it is just an ATAR that you didn't quite reach.
Thank you. And also we know that we have scholarships set up specifically for female students.
Yes.
Yeah. And speaking of women in engineering, I know that Claudia, you were very involved in the student society.
Yeah. Yeah, so Sydney Uni is really good with their student societies. We have so many, and one of the ones I was heavily involved with is SUI, the Sydney University Women in Engineering Society. So it's a faculty-wide society, and I was the junior vice president in my first year and president in my third year of my degree. And the work that SUI does is just trying to create a space where women can interact with each other, can feel safe, and I guess find a support network. So we run a lot of events aimed at connecting female students with female mentors in industry. We run Women in STEM evenings once a year. We have cocktail nights and high teas, and lots of kind of opportunities for you to hear talks about other women who have kind of gone before you, so you kind of get exposed to what some of the opportunities are for women, and you get exposed to kind of different career paths that you might not have kind of thought about before.
That's awesome. Thanks, Claudia. So I have one question about international opportunities. So the student says, I'm learning German, and I'm aware that Germany has a good reputation in engineering. Is it possible to take exchange in other countries than those listed like Germany?
Yeah. So the answer there is certainly yes, it is. We just didn't want to overcrowd the slide with too many universities, too many logos. I had a student a year or two ago went to TU Berlin for his exchange and quite enjoyed it and found it very useful. We have a long-standing exchange with Toulouse in the south of France. So if anyone who speaks French We'd love to send more people to France because they send people to us. We've had students go to China on exchange, Singapore on exchange. So basically, we've had students go to many, many countries on exchange. We're just putting some of the more common and longest standing ones on that slide.
Yeah. And if you want to get the details of exchange partners, you can just go to the Study Abroad website and list all the partner universities that we have. You can have a look where they are around the world.
Okay.
So now I have a question about the honors in the degree name, especially for those who are outside Australia. So how does this honors thesis work in the degree?
Okay. Right, so there's basically two types of honours degrees at the University of Sydney. There are some in, say, science, where you have a standard 3-year degree, and then your final year is almost all a research project called your honours year. And there are others where you've got a 4-year or longer degree, and it's normally a professional degree like engineering or some of the health degrees. And then in your final year, some of your subjects are a research project, and your honours mark is determined on all of your marks with an extra weighting for that research project. So for our final year students, they will do spend a quarter of their time on their honours project, a quarter of their time on a design project, and the remainder on specialist subjects that they've chosen.
Thank you so much. So now I have a few questions about the class size, class structure. So what's the typical class size?
Okay, so our standard class size is probably about 80 students. It goes up and down each year, but typically about 80. But through your degree, in first year in maths, you'll be in some quite large classes of 200 or 300, and that's why we'd recommend that you do the highest level of maths you can at school. So Extension 1 is our strong recommendation. We saw a question here earlier. Extension 2 is definitely useful, but it's not essential. Okay, so in maths and chemistry, you're in quite big lectures, and then in maths, you'll have smaller tutorials. It'll feel a bit more like your high school class.
Mm-hmm.
And in chemistry, you'll have some tutorials, but quite a bit of lab time. Now, for the chemical engineering subjects, you'll have a mixture of lectures, tutorials, group work where you're working on problems, and some practicals. And it depends a bit on what you're learning and what subject and which year.
Yes.
Thank you. So I have a question very specific. How can chemical engineering help with the agricultural production?
Okay, so there's a couple of interesting angles there. So first of all, you've got the production of fertilizers and the like. So that goes right back to Germany in the 1910 to 1918 era with Haber and Bosch and ammonia and fertilizer like that, and a lot of other agricultural chemicals. From a biochemical engineering point of view, there's a fair bit of research being done on how do you grow the right bacteria that you should co-inoculate with the seeds so that they have a symbiotic relationship and make fertilizers. There are quite a lot of other agricultural chemicals that are made by chemical engineers. And we've got someone who's recently joined our faculty at our school, PJ Cullen, who looks at plasma and making plasma to so ionized gases to actually help plants grow better through making more nitrates and the like for them. So there's quite a few different angles.
Thank you so much for sharing that. So now I have a few questions about preparing for a university degree while in high school.
Mm-hmm.
So are there any study method or tips you recommend for the high school kids?
I would try and focus as much on understanding what you're doing and remembering it as much as sort of the marks you need. Because it's very easy to focus on marks and then forget everything after the exam. But I'd sort of focus on understanding what you're doing
Definitely.
at high school before that. If you do that and you get that right, the marks will come.
I found that a lot of the time in year 11, year 12, people spend a lot of time, studying past papers, practicing with past papers, past HSC papers, which is really great. It's a great tool to have. But then you kind of learn the content to answer the question, not to understand what the content is actually trying to, teach you. So in first year of uni, in your first year maths and science subjects, there is a lot of overlap in the curriculum between what you learn in year 11, year 12 and what you're learning in first year of uni. So it was quite interesting to come and start going to lectures about maths concepts and chemistry concepts that we've been taught in year 11, year 12, but the way that they wanted us to apply those concepts was very different to what the HSC, questions were like. And so it really kind of was an interesting way to see, who had learned the content and understood it, and who had just learned to answer the questions in a really specific way. So I would definitely, agree with John in that you really need to focus on understanding the content.
And I think that really starts to become clear with a minority of students in their third and fourth year, where they've done okay in first and second year by remembering everything, but by third and fourth year, where they're having to understand and apply more, it starts to become an issue. So my thoughts would be at high school is to take subjects at the highest level you can, focus on understanding them, but of course you've got to put the effort into doing your exams well. So you do need to do the past papers and the like. But that will prepare you better than simply a lot of cramming then forgetting.
Yeah. I'd also say take advantage of the learning environment that you have at the moment. So like John said, some of the maths and chemistry classes in first year, have hundreds of students. And it's quite easy, if you can't go to a lecture, or if, you're just one student in a crowd of 200, you don't get the same, opportunity to ask questions as you would having a teacher in a class of, 10 to 30 students like you do in high school. So if there are some kind of big or general concepts, like maybe it's organic chemistry that you're struggling with, or, integration, I would take the opportunity to use the resources that you have now, because it'll make it much less intimidating trying to find help later.
Thank you so much. Good tips of dealing with stress and managing the workload. So we have another question about, are there any scholarships available for university entry into chemical engineering? So the university provide a variety of university level, faculty level, or the school level of scholarships. For example, we have the leadership scholarship, which is for students who have shown their leadership in the high school extracurricular activities, and they also have an ATAR above 98. But apparently that if they have demonstrated excellence in their leadership skills, we can also be flexible with the ATAR requirements. And for those students, they get 18,000 per year throughout the whole 4-year degree. They also get guaranteed placements. They can attend mentorship, mentoring workshops, and other industry engagement activities. So John, would you like to?
Yeah, I think there's likely to be a few extra chemical engineering scholarships for the next year or two, just because of a bequest that was made some time ago. So keep your eye on that scholarships advertisement page of the faculty, and they will be advertised there. And so you just keep your eye on that and apply for them. And the other point is that we do have in ESIPs a scholarship there for final year that's awarded to people based on how they're going in the first 3 years of their degree.
Thank you so much. Another question about exchange, how do your grades from exchange integrate into your marks for a degree?
That's a bit of a tricky one. Your marks from exchange actually just come back as you've satisfied the requirement for that unit. Okay, they don't actually come back as a numerical score. So those subjects basically don't count towards how your honours is determined.
Thank you so much for that. We also have a question about a very good one. So what do you think is the difference of studying CBE at Sydney Uni compared to other universities?
Well, Sydney's probably got a slightly smaller class size than some other universities, so that's one difference. We have a bit of a different approach with the way we teach some of our subjects, with giving students quite open-ended problems and saying, can you solve this? Okay, so the last couple of years with my fourth year class, I was making them look at a type of pollutant in the ground called PFAS and how would they treat that. This year we've given them the challenge, you've got a lithium ore, how do you make money out of it? Okay, and we do those kind of things even in second and third year.
Yeah, I would second that. I guess in my experience, you can only really speak to what you have experienced. So the small class sizes, you definitely feel it. There's so many more opportunities to have a closer relationship with the academics. You get more exposure to the academics, and that's really advantageous, especially when it comes time to choose an honours project. And you do get a lot of creativity. I think that's something that I wasn't expecting, but that I was really pleasantly surprised with. There is a lot of room for creativity when it comes to problem solving, and that really comes up over and over again in a lot of subjects, throughout your degree. So that's, I think, possibly the best training that you can have as an engineer.
Thank you so much. I have a question about if the student is not sure, like if they want to enter CBE now, are there any other options? So, or the student decide to change the stream of engineering in the degree, is that possible?
Yep, so there's two parts to that answer. First of all, we have an option back at enrolment called flexible first year, where you try a bit of each branch of engineering in your first semester to get an idea which branch you'd like to join. Beyond that, it's certainly possible to change. It's possible to change at the end of 6 months, at the end of a year, 18 months, 2 years. Beyond 2 years, it's probably getting a bit silly to change. You're better off probably finishing what you're doing, but you can change if you want to. The longer you leave it, it does generally tend to mean you'll need to do a few extra subjects. So if you change at the end of 6 months, it won't take you any extra time. At the end of a year, you might need to do an extra 1 or 2 subjects. At the end of 2 years, you're probably doing an extra semester, but you can change, and it's not wasted time. Okay, you'll see links and value in what you've learned before. And a percentage of our students every year will decide, look, I really want to do chemistry, and we'll be happy for them to have worked out what they want to do. And at the same time, we'll have science students come and join us. So don't feel that you can't change your mind in those first couple of years. A lot more people do than everyone realises.
Thank you so much. And continuing on that, we have questions about, the overlapping with other disciplines. For example, material engineering or medicine in a degree. Like, how flexible is our degree? Like, can students take electives from that or related areas of study?
Okay, so for people who are interested in materials, the faculty does have a materials major. It's currently best matched to mechanical engineering or civil, but you can do quite a few materials subjects in chemical engineering. There's a lot of materials research in chemical engineering. And if your interest really is materials, I'd look at actually doing a combined degree between engineering and science, where you can study the chemistry of the materials or the physics of the materials in a lot more detail.
I would say from a logistics point of view, other streams of engineering might have some shared subjects. So I know that some second year math subjects and I think some fluid subjects are shared between mechanical, mechatronics, civil, engineers, but chemical engineering after first year we really do break off from other streams of engineering, and you do specifically chemical engineering units. If you have a look at the course structure, in a double degree there's a lot less flexibility than a single degree, but even having said that, there are set subjects that you need to do every semester, and your electives that you need to fulfill are mostly, again, chemical engineering subjects. So the scope to take free electives from, maybe arts or sciences or medicine is not really there unless you do a double degree. So if that's something that you're really interested in, I would definitely consider a combined degree, because we are globally accredited, with the 2 accreditation boards. It's really important that our subjects meet those standards. And so to ensure that everyone has, kind of consistent training, there is, kind of quite a lot of structure around how the subjects are planned.
Thank you so much. We have another question about the support the student receive while they're become a current student. So because we mentioned that compared to high school is a very different learning style, are there still opportunities to meet personally or in small groups with tutors or mentors outside classes?
Yeah, so that's a really good question. I think we don't want to give the wrong impression. It's not that there isn't help. It's that you need to look for it, okay, or you need to ask for it. So in mathematics, the university has something called the Mathematics Learning Centre, which is set up to help people who are just struggling a little bit with maths. And there's also an English language version of that, an English writing learning centre. Okay, for other subjects, the first thing is to make sure that you go to your tutorial classes. And if you're there and you're struggling a bit or something's not clear, and you put up your hand and you ask questions, people will help you and explain things. The danger at university is that you don't have to be there, and we don't know who isn't there and who is struggling. So if you are struggling a bit or in any subject, there's no shame in sort of asking either your tutor or your lecturer, look, I'm struggling to understand this, and they'll give you some help. So there is actually quite a bit of help there. Also, in our first year, we typically have a tutor allocated for first years who are just struggling a bit with one subject or another. Okay, we have a special tutor also allocated for our international students who might be struggling because they're listening to people talking in a funny accent in class. It's a different style of class and so on. So we do have some help there, but you do need to ask for it.
And every academic, or most academics, will have drop-in hours once a week or once a fortnight where you can go, during maybe a lunchtime or whatever it might be, and just drop in and ask them questions specific to courses. But something else that I was really surprised about is there are a lot of shared spaces in engineering for students to study in. And if you go to some of these shared spaces, there will be so many engineering students from all streams who are willing to help you. If you have a question about, first year maths or whatever it might be, you can just call out and ask, and someone will be more than happy to come over and help you. So there's a really good kind of camaraderie between engineering students that is a really helpful tool to have.
Another question about studying at the uni, like how many hours per week would you expect to work in lectures, tutorials, etc., and how would this vary in a double degree combined with science?
Okay, so for a standard degree in engineering, we typically expect you to be spending about 40 hours a week on your classwork. Okay, now that could be in class and out of class time added together. So you'll probably spend, say, 28 hours a week in class in the first year.
I would say, around 28, 30 is probably what it...
And maybe 10 to 15 out of class. Then as you go towards your final year, you might only be spending, say, 16 hours a week in class and 25 to 30 hours a week doing your work outside of class. So,
and in terms of how that changes, if you do a double degree with science, the kind of main difference that I noticed was that science obviously have a large practical component to their subjects. So in your first year, you might have 1 3-hour prac a week. As you kind of go through your degree, you might be doing 2 or 3 science subjects a semester, and they might have, each 2 3-hour labs per fortnight or something. So you end up having quite a lot more kind of contact hours through those science subjects because you'll be required to do more frequent labs that kind of get longer in duration as the experiments get more complex. So you definitely have more contact hours as a combined science student as you than a straight engineering student. And I would say you also have more hours doing combined science than you would if you'd combined with commerce or arts or something like that, just purely because they don't have those long practical requirements.
And the question about assessments, are they just reports or other forms assessments also?
No, you'll get a mixture through your degree with each unit of study. And actually, if you go onto that website Claudia mentioned earlier, CUSP, you can actually see them spelled out for every unit that you take. But essentially, in the first year or two, there'll be quite a few exams. And then sort of in the middle years, you'll have quite a few reports. And in the final years, there will still be some exams and quizzes, but your assessments will be far more heavily on design reports, thesis, and so on. And along the way there'll be some oral presentations.
There might be some take-home assessments.
Some people use take-home exams. So there's a bit of a mixture there. As a general rule, we're trying to use an assessment that matches the skill that you're learning. So if you're being tested on whether you can design something, then we're going to mark a design. If you're being tested on whether you understand a concept, then we might just give you an exam question. So there's a variety there.
One thing you won't have are essays. I don't think I've written an essay since high school.
There might be
one or two. Okay, depends on subjects.
Thank you so much for sharing. So sorry everyone, we have to wrap it up here. Thank you all for taking the time to join us this evening. And thank you to John and Claudia for sharing the insights. So if you have any further questions, please send your questions to the emails that on the screen, which is engineering.outreach@sydney.edu.au. And have a lovely evening and good night. Thank you.